Okay, so we are on to Chapter 4 of An Introduction to Statistical Learning, in the second edition. So we are in the conceptual parts and question 1. Question 1 deals with logistic regression. Now, if you remember in the previous chapter, in Chapter 3, we saw equations kind of like this, although it was just, like this. Right, and some output y or outcome y was equal to our linear equation that might look something like that. And now we are here discussing logistic regression, and with logistic regression, we are generally trying to find something like the probability of something, right? Which is bounded between 0 and 1, or we are trying to find something like the odds of something, and this is the formula for odds here, right? Which is not bounded between 0 and 1 necessarily, but our outcome variables are no longer linear, right? And so we have to do some maneuvering in order to be able to use our nice, usable linear equations. Okay, and that's what logistic regression is for. That's just too much background for what is demanded in this question. But in this question, we want to demand, or we want to use a little bit of algebra to prove that equation 4.2, which I've replicated here, is equivalent to equation 4.3, which is represented there. I want to point out that the book uses an expanded version of these linear parts, right? Where I'm just using xb. The book is using beta naught plus beta 1x. That's just too much typing and kind of clutters up the screen. So if you really wanted to, you could just substitute in this longer version for what I've done. So in other words, show that the logistic function representation and the logit function representation of the logistic regression model are equivalent. Okay, so I won't step through the entire proof, but I kind of, maybe I will. So I like, whenever I have to derive this for myself, and I do often, I will start with the odds, and this is the definition of odds. Okay, now again, the book is using p of x, and I'm just abbreviating that with p. Okay, and the logistic function is the logistic regression is the log odds. Okay, so here's log odds, and it's the log odds that is equal to our linear model x beta. Okay, and so if I exponentiate both sides, so I exponentiate this side, I get p over 1 over p. That's just the odds, right? Because exponentiation is the inverse of log. Okay, and so that means that the odds is equal to our linear model exponentiated. Okay, and now, and so this is actually equation 4.3, and then with the algebra here, we can back solve for p, and so I'll let you step through that all by yourself. But in the end, we get that p, or p of x, right, is this stuff here. Well, this is equation 4.2. Okay, that's it for this one.